So we are given a function and I don't care about it in this given interval. I want to find increasing, decreasing interval. Well, that is to say you want to know where the derivative is greater than or less than 0. So first thing first, you need to know what exactly is the derivative. So everybody should be able to find this out relatively easily, which I'm not going to go over again. So in order to find whether something is greater than or less than 0, it's easier to find where it's exactly 0 first. So I end up with f prime of, my bad, I end up with 3e to the 3x minus e to the negative x being 0. That is to say 3e to the 3x is e to the negative x. So we end up with 3e to the 3x times e to the x being e to the negative x times e to the x. So we have e to the 4x equals 1. E to the 4x is 1/3. This requires you to be able to recall what you learned from pre-calculus. So 4x is natural log of 1/3. So x is natural log of 1/3 divided by 4. Okay, so this is what we end up with. And when you input in calculator to estimate what exactly is this value, I highly recommend you to be very careful about the way you input it, right? 1 divided by 3 divided by 4. So the calculator would tell you it's roughly speaking, okay, very rough, estimation is 0.27. I ignored a lot of digits behind that. So when you use things to in the final answer, make sure you use the actual number, do not use the estimations. So let's continue. Now what you know is I care about what's going on starting from -2, right? This is starting from -2 all the way to the right. You do realize your function at this point has a derivative of 0. So all you need to know is somewhere here and somewhere here, what exactly is supposed to be the sign of the derivative. So you go ahead, you plug this back into your derivative. It is 3 times e to the 3 negative 1 minus e to the negative of -1. It's 3 times e to the negative 3 minus e, right? If you plug it into the calculator, you will realize this is something that's actually less than 0, because this is greater than 1, this is less than 1. And then I have f prime of 0, which is 3 times e3 to the 0 minus e to the negative 0. 3 times 1 minus 1, which is clearly greater than 0. So knowing this is the derivative here is less than 0, that's greater than 0, you realize your function goes down because it's decreasing and it goes up. So you can find your increasing interval is from natural log of 1/3 divided by 4 up to infinity, and your decreasing interval is going from -2, actually close bracket, up to ln of 1/3 through 4, open parenthesis. Okay, so this is what I have as increasing, decreasing interval, and according to what we learned in class, this clearly is a local minimum. So the problem said you are going to write down the answer by telling the system where exactly is this, and write down a minimum to denote the fact that it's a local minimum. So this is your first answer, your second answer, and there's one more answer. I have another comment, because if you input this into your system, you will realize the system tells you it's wrong. Well, this is a problematic issue. The final answer in the system that was programmed is wrong. Okay, that is wrong. I want to tell you that first. However, if you want to look good on paper on web work, you probably want to type this in. But again, this is a wrong answer, what I'm going to talk about. Because we said when you talk about local min, local max, it's a local idea, so it can never be on the boundary. Not on the boundary. That is to say, this point, the very end point, should never have been your answer, as if you are simply looking for local min, local max. Absolute min, absolute max, yes, they can be answered. But local min, local max if you are local, you should be able to find neighbor on both sides. If you are a boundary point, you don't have anything on the other side, so it cannot be a local min, local max. However, the system didn't program the answer properly, so I'll just tell you what errors to put in. So clearly, starting from here, you will be going down. So the system made a mistake, thinking this is a maximum, even though it cannot be treated as a local maximum. So what you have is -2, and it's a local maximum. That's what the system think would be right. But one more time, it's not conceptually correct. Please don't use it in your quizzes, in your exam, and in anywhere else. And no other problem made this mistake. So I just want to point that out to you. But you probably want to go over the previous steps a little bit, because the calculation is slightly more challenging than the polynomials which we discussed in class.